formal definition of a data structure is that we can use some source where we can store our data and we can use it effectively. When I say effectively, what does it mean by effectiveness? Can anyone guess? What is effectiveness? So when I say I want to use data structure with effectiveness, I understand that I'll use a proper time complexity and a space complexity. I hope everyone would be aware about time and space complexity. Right? Yes, agree. Someone said that logical representation of a data. Perfect. But my definition is how to use data or store data effectively. So this is a formal definition that I would use. That data structure is a way of organizing, or I would say storing the data such that I can use it effectively, both in terms of space and time. Correct. Now, most of you would be aware about time complexity and space complexity. Will not go into much depth of how to find it out. What we can say, annotations and definitions of that. But in a simple term, if I explain you the time complexity and space complexity, it will be something like this. Just a layman's perspective that will be used in interviews as well. Let's say if you are storing n numbers in an array, let's say 1, 2, 3, 4, and 5, you are storing, then it is called as order of n space complexity. What is this big O, small o, and all that things, right now they are not useful in terms of industry standards and all that things, because in industry we use only big O. Okay, so Book's explanation of big O and all that things we are not taking. I'm just giving you in a layman's perspective that if you are storing n numbers, it is called order of n's complexity. And if you store n into n size, just like in 2D array, then it is called order of n square space. In the same way, the time complexity, if I write a loop something like this for I equals to 0 to I less than n and I plus plus, and I operate some of the things over here, then it is called order of n. But the definition of order of n is this: all operations should be of order of 1. When I say order of 1 means it can be a equals to a plus b or something like that, which can be performed irrespective of value of n. Then it is called order of n. Now, whenever we see some interview question, at that time I'll explain in more depth that what if there are multiple for loops, what if there are recursion, then how to compute the time complexity. At that time we will take. But this is a primary knowledge of time and space complexity. Clear? I hope this everyone would be knowing it. Let's take further and explain about the type of data structures. As I said, there are primitive, some of the data structures are of primitive type, which are called integer, float, and so many other. And non-primitive data structures, where we are actually looking right now for interview perspective, they are linear, non-linear. Linear means array, linked list, stack, and queue, which grows linearly in terms of array or stack, whatever you say. It grows one by one. Okay, and non-linear are in which the relationship between two values are not one by one, but they are different. They are called as tree and graph. We'll see in representation wise, we'll see how pictorially it's represented, how as per the code they are represented, and we'll see how they are interwoven into interview questions. Okay, so let's get started for the next slide. And before that, have anyone doubt so far? So we'll take such steps, we'll take such pause, and we can ask about the doubts. So yeah, I'll explain about the time space complexity again, okay, whenever we'll take the interview question. Perfect. So what's the difference? Yeah, so this was a slide for primitive, non-primitive data structures, linear and non-linear. These are just the example. Okay, now let's get back to the differences between those. As I said, the relationship or the structure of a linear and non-linear data structure is a primary construct from where they are being defined. Correct? Consider, let's say, linear data structure. Their arrangement is in orderly manner, one after another, and in non-linear, they are not in order. The relationship between two nodes, I would say, they are different way. Traversing would be a single one, like in order of n, you can easily traverse it, just like let's say you are iterating over array or stack. In like in a single for loop or a while loop, you can access it. But traversing the non-linear data structure, it's a complex one. You'll have to use recursion and something else. Correct? We have the relationship with previous and next. So we know, let's say, even if it's an array, and if you are at ith index, you can go to i+1 or i-1, or even if it's a linked list, you can go to the next, and if it's a doubly linked list, you can go to the previous. So the relationship defining is much more easy or simple, I would say, in linear data structure, but not in non-linear data structure. Non-linear data structure has parent-child relationship. Correct? That this is the parent and these two nodes are child. In such a way, non-linear data structures are defined. We'll see in detail. It's just a normal formal definitions. Okay.